Solve the equation 3z cubed minus 14z squared minus 28z plus 24 is equal to 0, given that the roots of the equation form a geometric progression. So, given that the roots of this equation 3z cubed minus 14z minus 28z plus 24 is equal to 0 form a geometric progression, then they may be written, these roots could be written as a over r, a, ar. I know we could write them as a, ar and ar squared, but this keeps it really simple. We don't have a squared for the r. Now the product of the roots, this is what this means, is minus d over a. So a over r, a times ar, and writing it this way means that the r's will cancel out. So d is going to be minus 24 over a, which is going to be 3. And then the r's will cancel out, and then we get that a cubed is going to be minus 8, and therefore a will be minus 2. Now just be a bit careful here that don't confuse this a with this a here that we've used for the comparison, because they're different, as you can see. And this is the one that we're going to need for the roots. The sum of those roots, so that's doing a over r plus ar, will be equal to minus b. So b is minus 14. So minus 14 is 14 over a from this expression is 3. If we now substitute our value of a in from here, this is where you've got to be a little bit careful. You're going to take minus 2, because a is minus 2, and you'll be left with 1 over r plus 1 plus r is equal to 14 over 3. And then I'm going to multiply everything through by 3r, which will make that minus 6. And this will make this side 14r. And this will make this side minus 6r. So this will become minus 6, 1 plus r squared. Just get rid of the fraction there. It's equal to 14r. Multiplying through by minus 6, we get minus 6 minus 6r minus 6r squared is equal to 14r. We like to make the squared term positive, so that will give 6r squared. And take that over there, we're going to get plus 20r plus 6 is equal to 0, and these are all divisible by 2 to get 3r squared plus 10r plus 3 is equal to 0. Just need a little bit care at solving that quadratic. Right, solving the actual quadratic itself. Okay, I've used the calculator where you're going to use product 3 times 3 is 9. Sum is the number in the middle, and then two numbers which multiply gives 9, and add, you get 10, obviously 1 and 9, and then you get 3r squared plus r plus 9r plus 3 is equal to 0. Then you group these two together, the common factor of r, and you get 3 plus r1, and then group these two together, bring down the plus, so you're going to take out 3 as a common factor, and we're going to get 3r plus 1 and r plus 3 is equal to 0, which gives that r is minus 1/3 or r is minus 3. Remember a, when we solved the original this equation, we got minus 2. So the roots of the form, well, there's a over r, so it's going to be minus 2. We're going to take r as minus 3 to begin with, because it's an integer value. It's minus 2 over 3, minus 2, and minus 2 times minus 3. So it gives me 2 over 3, minus 2, and 6 as the answer. It does actually work for this one as well, but just that if you use r as minus 1 over 3, we'll give the numbers in the reverse order. Okay, so this has been a video to show you how to solve an equation whose roots form a geometric progression. I hope you've understood, and I thank you very much for watching.